Hello and welcome again to the podcast, Dr. Oluwasanmi Olumuyiwa or Olumuyiwa Oluwasanmi. One of them, one of the other two. And I know you get, I know you get upset whenever I do
This
that.
is
It's
weird.
like,
No, no
why are you
one.
calling
I'm not
your
a.
name?
It's only medical doctors that typically use the title that way. It's kind of weird,
Right.
right?
I
Olu for
say
short is
welcome.
fine.
Okay. I
It's
say I
fine.
say welcome because we've
Yeah.
done this before, but the other one we had network problems, connectivity problems, but I'm
Right.
always happy talking to you online, offline, and I'm hoping that this would
Right.
be a great session to get people to know your story
Right.
because your story is very, very inspiring. Um, I met Olu, as he wants me to call him, even though traditionally
That's the way it works.
I can't
That's the
call
way it
him by
works.
that name.
I mean, the first professor I ever met in
Yeah.
America, and when I called him professor, he was like, "No, my name is Bob." And it's hard.
So you
If he
understand how
was,
I feel.
yeah. So if he was in his 60s and he was saying, "Well, my name is Bob," the same way my name is Olu too. It works that
Okay,
way.
fair enough. Welcome again, and I want us to use this opportunity to talk about your story, and at the same time, talk about things that you said you wanted to talk about that we usually talk about over the phone, but
Hmm.
we'll put it in a conversational style to let people understand the mystery of living in the US versus visiting. So I'll
Right,
start out with your background from Nigeria.
right.
Um, you did study in OAU in Ife,
Correct,
and
correct.
what was that like? How did you get to study what
Oh
you
wow,
did?
that's a very interesting question. So, me, I've always been fascinated with math ever since I was
Right.
much younger. So, but I felt my parents were like, nah, it's not a professional course. It's not accounting. It's not pharmacy. It's not medicine. It's not some form of engineering. None of this
Really?
math stuff. You're just going to go hungry and stuff.
Wow.
Uh, so I actually filled my JAM form as computer science and engineering to OAU. Um,
Okay.
and I did get into that, but by my second year, I hated it. It was boring. I would probably have ended up dropping out of school at the rate I was
Okay.
going because it was just, eh,
Really?
yeah, because it was not stimulating. I wasn't interested. And so in the middle of my second year, of the first semester of my second year, or was this the second semester of my second year? Um, so I shifted to computer science and math, and we were only three in that class.
Wait, so you started
So
out with
OAU,
electrical
OAU has
engineering?
so the computer science and engineering department in OAU has three different divisions or three different
Okay.
courses under that department. So
Okay.
there's computer science and math, computer science
Okay.
with economics, and computer
Okay.
engineering. So I was in computer engineering, so I transferred to computer
Oh,
science and math. Uh, yeah, my
right.
father he was like, "Why are you doing this stuff?" We thought none of this math stuff. My father was almost like, well, I think you should come and sign an undertaking so that if it doesn't go well for you, no one would
Oh,
blame me. Yeah, he
he
said
did
that.
that?
Yeah, he said that. He said I should come and sign an undertaking so that if it doesn't go well for you, no one would blame me. Because, parents are worried, if it's something that they don't understand, you know,
Yes.
they're
Correct.
always going to show how they feel about that, especially in Nigeria, because according to them, it's not a professional course, right? Um,
Wow. Okay.
and
It's a
I
first.
big shout out, I always like giving people a shout out that helped me along the way. Dr.
Right. Right.
Olu of OAU, he
Okay.
actually, I'm sure he's a professor now. He really helped me, and he said, "Well, okay, if this is what you really want to do, I'll help you." So a
Okay.
few weeks, like 2 weeks before the exam, my department changed.
Oh, wow.
And, yeah, and now I had to sign a whole slew of courses, and then I had to catch up.
Okay.
So I ended up almost doing maximum credits till I graduated. It was the only way I would have graduated with my mates.
Oh, okay. So
So
you
so
had
so my
so this
course
was
load so my course load would be more than the average person's. Yeah. So
so let me get this straight. You were in what year when you did this switch?
second year. And
Oh,
I'm forgetting, maybe it's the first or second. I would say it's the second.
okay,
Yeah.
okay, okay.
So and I did that switch. I'm glad I did. So the rest is history.
So what is this fascination with math?
I just don't know. I don't know how. So let me even start. So I
Okay,
wouldn't even say I was really good at it because
okay,
now I got diagnosed in my early 40s, ADHD. So,
okay,
but then my mom had this lesson teacher. Um, Let me not name names.
okay,
It just to protect the innocent. And this lesson teacher
okay.
was extremely strict. And let's just say the caning was
Yeah,
very effective.
very effective.
Yeah. So you couldn't protect any part of your body. If you covered your
Yeah,
head, then she went
right.
for the
Like
back
dodge.
or the bum. So
Yeah,
you couldn't.
couldn't protect
Yeah.
any part.
So
Yeah.
so in order just not to get caned, I just got good at it, and
Okay.
I found out that I could solve problems also in my head,
Right.
right, rather than writing them down. I think that was the other
Right.
thing that my imagination, because I've always had an active imagination, so my imagination kicked in, so I could imagine the problem. So that really helps. So in order not to get caged, you solve the problem ahead of time, and then
Yeah. Fair
she'll
enough.
come. Have you solved the problem? I gave it to you. So, no, I solved it like yesterday. It's this. Hmm.
Yeah.
So and this is how I
The
avoided the
fear.
game permanently, right? Because
Yeah.
at one point in time, you know, I started playing truant even on the extra lessons because uh, the caning got so much that my mom had to have a little word with the teacher that,
Oh my
hey,
days.
this kid is a little bit too if he's playing Tron, you know, but these are the little things that shift a society in a positive direction. Because some kids, and I know some kids that some of my mates then, or maybe a year or so younger, that
Right.
this treatment completely sold them of math for the rest of their life.
Oh, they never liked it as a result.
They never like it because they associated it with this treatment,
Oh,
right?
that's true.
Right.
That's true.
So,
That's true.
so you see what I'm saying? That
Yeah.
sometimes, and that's why I don't want to mention names because I know, a lot of times our people did things and they didn't really know what they were doing.
Yeah.
Just
True.
because they tried it with some people and it worked, but the cases that it didn't work, they
Look,
didn't use it to understand why it
and
didn't
why
work
it
for
didn't work.
them,
True.
right?
True.
And trying to avoid being getting caned is the worst way to find out you love something.
Yeah.
It's the worst way of
Very
finding out.
weird. Very
Yes,
weird.
no, weird is an understatement. It's the worst way of finding out.
Right.
You're trying to, just because you're trying to avoid punishment. For some other people, they're not able to make that association, and they now
Right.
miss out on a career that they could have had,
Right.
or something that they could have loved.
Yeah.
That could have been of benefit to society and humanity. See,
That's
and
true.
all that is gone.
Well, well, we have you.
But
who
I'm still
benefit
here. I'm still here. We're
who
still here.
benefited
We're
from
still
that.
here.
Yeah. So
We're still
so
here.
how so in your university days, how did what skills did you pick up? Because I know you one of the most prolific software engineers I know, and
Right, but the
knowing
software engineering
knowing
is
what you know.
actually, okay, let's talk about that a little bit. So the software
Yeah.
engineering is actually an aside. I told you the math thing. So the math
Okay. So
thing,
okay. Go ahead.
let's actually fully explore the math thing. We'll segue back to the software thing because
Okay. Okay.
they're linked. So I told you about the lesson teacher, how I was avoiding that. And
Right.
so when I got in the second, and so my father, he had bought books, so we have had a family library even before I was born. Like I was born
Right.
sixth out of seven
Okay.
kids, so there was
Seven
already a
kids. Yeah.
family library. I mean, there were all sorts of books, Shakespeare,
Right.
even books such as what you would call it, Machiavelli's The Prince. They were
Oh. Right.
available. So,
Yeah.
so,
Right.
I
Right.
mean, surprised. So there were some calculus books, and so I remember the 1978 Guinness Book of World Records. I remember reading about some 4 year old that understood calculus. I'm like, hey, I'm like, and I was in secondary
Ah.
school. I'm like 11, 12, 13. Maybe I was like 13, maybe my second year of secondary school. So there was a calculus book at home. Just picked it up, and that was that.
Wow.
Just like that.
What's
And
the title of that book? Do you remember?
so there were a couple of them. There's one green textbook that I don't remember its name, but
Okay.
the one that I really learned a lot of techniques from and really learned it fundamentally was a book called Teach Yourself Calculus. I don't know if they
Oh, okay.
even if it
Printed anymore.
exists anymore. I think it's a Teach Yourself series. I don't know. I've forgotten the
Oh,
publisher.
okay.
Yeah, but
Let me
that's
look
how
it
I
up.
learned it. Yeah, and I did that up to differential equations myself.
Oh, wow.
When yeah, that's how I learned that in less than a year. Because
In
it was
less than a
fun.
year.
In less than a year. By the way, I learned how to read in the same checkered way. You know, my eldest sister got back from she incidentally went to AU herself, and she was like,
Okay.
she bought me a book about
Yeah.
Avril, this apricot that
Okay.
couldn't sleep, and and I couldn't and I couldn't read. She was like, "What? No." Yeah, so with the same method as the teacher was saying, like, uh-huh.
Teacher. Yeah.
Yeah, yeah. That's how I learned how to read under the cane.
Wow.
The
Yeah. It looks like brute force works for
brute
you.
force, but again, I mean, this was what people knew. Then there
Yeah.
are other ways of teaching kids how to read, right?
Right.
But it was what they knew, but it worked. So by 5 and a half, and there were lots of books at home. So you can imagine now
Mm-hmm.
this kid can read. Lots of books at home. He's going to read whatever is available. So that's what
Right.
happened. The James Hadley Chase, everything, M&B's, whatever.
Oh, okay. You went
Oh
through all the
yes,
whole.
yes. We won't go into
Okay.
that. We
No,
won't
there's
go
no
into that.
need.
So
It's out there. Yeah.
yeah. So that love with math just continued after the experience with the lesson. I taught myself calculus. So by the time I was in year two,
Yeah.
so the people in year five, year six,
Right.
in my secondary school, I was one helping them with
Oh, wow.
calculus because I understood it.
You understood it.
It was easy. It just made sense to me.
Yeah.
I'm like, this is easy.
Yeah.
But and so it happened that way, and of course, got to university, did computer science and math, like I mentioned about the switch.
Right.
So the how did the software engineering come?
Yeah.
So before I did the switch,
Yeah.
right? My brother-in-law, God bless him, I'm so because when I was in university, I lived with my sister.
Okay. Okay.
The eldest, the second of my sisters, because I have five older sisters, right? It's the
Okay.
second of them. So I live with her and her husband and their son, who's my nephew now. Incidentally, my nephew's married with the son
My-
too. That's so he, my brother-in-law sent me to a computer school. Yeah,
Oh.
yeah, he did. And I was like, this thing is. Well, at first, it was hard because it's like it's
Uh,
another language. So
right.
and there, that was where I picked up basic Fortran, DBase,
Right.
Clipper, C.
Okay.
That's my
See.
introduction to
Right.
it. This was this 94, I would assume. It was
Okay.
94. So by the
Before.
time I came, because we had this long holidays because of strikes and during the
Right.
Abacha military regime.
Okay.
Um, and so by the time we were back, I think we got back the next year in 95.
Okay. Okay.
Our matric numbers say 93, but we didn't
Right.
get in until early 94. And
Right.
so in the middle of 94, I think when there was a strike because remember the socio-political upheaval because of
Yeah.
Abacha then. And so we ended up spending like a year home, so we came back in 95. And by that time I had done this computer school thing for about a few months or so. Okay.
Oh.
So
Okay.
right. But of course, that was where you had access to computers. And so,
Yes.
which I already knew a little bit about computers before, but now programming. But
Right.
the thing is, that you still had to share computers,
Yeah.
right? And so, you had to write stuff on paper, right? And so
Yeah.
you had to get familiar with the syntax and all that stuff,
Yeah.
doing interesting
Dry
things in
programming.
QBasic. There was still
Yeah.
64K of memory
Memory.
limits, at least in the computers we had then. We played with mostly 286s and 386s then. Um, and so that's how the software engineering side of things came, right? And I found
Oh,
out I liked that too. And so
okay.
that influenced my switching because the computer science and I'm like, I don't like this engineering stuff. It's not fun. But
Okay.
I
Now I
can do this
understand why
math now.
you do
But
this
this
now.
computer science thing is also somewhat okay. So I can.
Right.
So that's what informed the switch. Right.
Okay. Okay. So but that still doesn't explain something that you do very well. And you might laugh when I say this. How did you get so good at computer architecture then?
I, it was one of the courses. You know, I wouldn't say I was. I don't know. Maybe good is
I'm the judge of that. Let me
okay.
be the judge.
Okay, but I would just say by osmosis, really. You know,
Okay.
we did have computer architecture classes and mildly interested in the hardware and you know
Right.
the evolution all the way
Right.
from the first x86
Right.
8088 to 8086 8086
Mm-hmm.
8088
Oh,
18 the 186 286
yeah.
386
386, 486,
486 right
and then Pentium.
yeah
Yeah.
yeah
Okay.
so
So
all that.
so would you say it was because of the nature of programs you wrote that you had to know the architecture so you don't blow up the
Right,
architecture?
and you remember, even right now, maybe now there's some architectural diversity coming back. There's very little architectural diversity now.
Okay.
Then there still was. Most people don't even remember that Microsoft used to actually sell a variant of Unix called Xenix, right?
Right. That's true.
Yeah, which was deployed on mainframes, right?
Right.
Right.
Yeah.
There
Yeah.
was
That's true.
DEC back in the day,
It was Deck.
right?
Yes, I
There are
remember Deck.
interesting computer manufacturers like Wang that I'm sure nobody
Yeah.
has heard of now
Yeah.
that existed then.
One computer. Yes.
Wang computers, there was Tandem,
Yeah. No tandem. It was
there
this British
was
guy.
the Control Data Corporation.
Yeah.
Fujitsu had their own, IBM had their own
Fujitsu.
mainframes. Bull from France.
Right.
Those are names you probably most people haven't heard of now.
Yeah.
So there was quite a lot more architectural diversity then, you know. And I mean, you know, apart from the personal computer, there were MIDI before you
Yeah.
got to mainframes, right? So
Yeah. Yeah.
there was quite a lot more architectural diversity back in the day than
Yes.
now, right?
Yeah. Yeah.
So that's another thing.
Okay. 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 So how did you? So I'm looking through the questions here. How did you then transition from IFE to coming to do your grad program in America, and how did you find the school? Did you was there someone that you reached out to? Were there mentors that
So
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 how did that transition work?
so part of, like I was mentioning, there was quite a lot of architectural diversity earlier in the computer industry, and so
Right.
because I'm very to a certain extent I'm a slight computer history buff,
Right.
and so I had the idea of I was aware of how the computer industry came about, all the
Okay.
way from the Hollerith tabulating machines to the ENIAC, and
Right.
why we had such computers,
Right.
uh, the new Manhattan Project, all that,
Uh-huh.
right?
Yeah.
And I was like, okay, there are a couple of centers where the computer industry existed back in the day. There's the East Coast, of course, which
Yes.
IBM is a linchpin. The MIDI
Right.
computers were mostly around Minnesota because that's Cray and all that,
Yeah. Great.
right?
Yeah.
There's the West Coast, Washington, New Mexico, and
New
Silicon
Mexico.
Valley, right? New
Right.
Mexico because of the
The Manhattan
nuclear
Project.
technology and Manhattan Project, right?
Yeah.
So, so I was like, okay, it has to be one of these centers, right?
Oh, one of those centers. Okay.
Right. So pick one, and I did apply to several places. But then, since New Mexico is where Los Alamos is in Sandia, so I
Yeah.
was like, okay, computer schools have to be good because they have to work
Yes.
with current technology too. Because without a computer industry, uh, there's no Department of Energy. So I was like, okay,
True.
yeah.
Okay. Okay.
So
I get your
and
logic
that's
now.
how I ended up applying to the University of New Mexico, right?
Okay.
So yeah,
Did you
which
apply
is
to any
where
other schools?
I did. I applied to the highbrow schools. Of course, I didn't get in, you know.
Okay.
But of course, and that's part of the issue of coming from Nigeria. But you know,
Yeah.
you play with what you got,
Yeah.
and
True.
I got accepted in the University of New Mexico, and
Okay.
the rest is
What
history.
did you get accepted for?
Uh, Computer science, PhD in computer
Computer science.
science,
Was it a master's or a PhD?
PhD. Yeah.
A PhD. So how? So that's the. So how did you convince you this guy, this kid out in Nigeria? What did you tell them you wanted to solve? I mean, there must have been something that you used to impress them for you to get the
I don't know.
PhD.
I wouldn't characterize it as such. I mean, when you start getting to graduate school, being impressive is a dime a dozen.
Okay.
The issue is always capacity and
Okay.
resiliency, the ability to complete, right? Because most people
Right.
start a PhD program, they're not able to finish it because of one thing or the other. It doesn't mean
Yeah.
they're not as smart or they're not as impressive. There's life, and all
Right.
those complexities. And so, uh, I think the only thing I could say was I told them I was interested in this field and why.
Right. So what did you say you wanted to do?
I thought I was going to do some sort of parallel computation thing. And
Okay.
the more I knew as I got into the program, it shifted more to distributed systems. Uh,
Right. Which is some form of parallel systems as well, but distributed in a
I
way.
mean, yeah, but people will say distributed systems is kind of a superset. Parallel is just a subset of it. Yeah.
Okay. Okay. So when you got to to the university, how did you how did you get a job? What
So,
was
so, so.
that thing
Okay, well,
that you
so
did?
in Nigeria, I worked in the IT industry too before I left for the
Okay.
US. And so the university at that time told me they were out. Typically, most people, PhD students get teaching assistantships eventually because
Right.
there's actually a teaching requirement as part of the
Right.
PhD program, right? But they were out of teaching assistantships and even graduate assistantships.
Right.
They were out of. So they say next year, but there are all these other people that offer assistantships, right? So
Okay.
there are all these departments that want stuff done. So there was one in Department of Biology.
Hmm.
Servieta Research Long-Term Research Program is one of them. I've forgotten. Oh, New Mexico Heritage Program. I must be very
Okay.
precise. Yeah, so because I had made a lot of friends, good friends there. And
Right.
so
Right.
when I got there for the interview, and I saw the guy working
Right.
on SQL Server,
Ah,
and he
I
was
remember
having
this is the
trouble.
story.
I was like,
Yeah.
ah, you
I remember the
coming to my
story.
house
So
and the
yeah.
spider to the fly. I was like, oh, you're working with SQL Server? He said, yeah, he's been trying to convert their database from Access to SQL Server. I was like, no problem. I've done this
Yeah.
kind of thing. I say, oh, you're trying to debug it. Oh, that you can actually, there's a certain flag that you need to set so you could actually step in and step out and actually debug on SQL Server natively now. So can you actually do that in SQL Server? I was like, oh, of course. I'll show you. And I just set the flag,
Yeah.
and presto, he could step in and step out of the coda. But like, how did you learn how to do that? I used to do that for fun. I mean, and that's how I got the job. That's how I
Oh
got the
wow.
assistance.
That was your interview.
That was like my interview.
Okay.
That's how I got
So
the
what
job.
were you doing
Very,
for
very
them?
nice guy. What the New Mexico Heritage Program is, the heritage that they're trying to preserve is New Mexico native plants.
Oh,
So
okay.
there's
Okay.
GIS problem. Part of it was where it's located. Where did I look at see this plant? The instances, right? And then there's the data part of the problem, right? And saying,
Okay.
okay, this plant, this species, and all that stuff, great biological stuff, right?
Right.
Uh, so. they were trying to maintain this database over time.
Okay.
Okay,
Okay.
and so I helped them convert from Access to SQL Server,
SQL Server.
right? And then integrate. It has to integrate with ArcGIS, right? Because of the
Oh,
GIS
okay.
component. Because you need them
Right.
to locate this. Which these are the little things about a society sometimes that you appreciate that
You
they know
appreciate,
that
yeah.
the fact that they have these plants growing is their
Right.
heritage that they have to preserve, which I find
Yeah.
very, very
Mm-hmm.
absolutely fascinating. Right.
Okay. Okay. So this is, you're going through the program. How did you get any internships? So I'm going through the question here.
Okay,
Did you
okay.
get any
So,
internships as a grad student, or is it just research?
before I would say I did do some OPT, you
Okay.
know, right? And later, I actually got a job for a company that was actually manufacturing radiation detectors, but that's another
Oh,
story. Yeah.
okay.
Uh, and so, what this company was doing was that they had this legacy code in Fortran that
Okay.
did all this stability calculations or engineering mechanics calculations for concrete and
Okay.
beams and all that interesting stuff. And I helped them, and they wanted to modernize the code.
Okay.
Also, because the person that had it in Fortran, they didn't really understand what was going on. And then the other
Okay.
problem was, uh, it they needed it to modernize it and kind of, how should I say, it would help now if they modernize it. Now they own the code. They don't have to necessarily be paying someone for this, and so they just needed
Oh,
help
okay.
doing that conversion. So well, it's Fortran. Done
Right.
Fortran for donkey years. We used to write it in paper Fortran 77 back in the
Yeah.
day, right?
Right.
So okay, this is right up my alley. Just converted it to C sharp, showed that it
Okay.
did the same thing and did the calculations correctly,
Okay. Okay.
and so that was valuable experience, at least in the
Okay.
field, to know that well, people have all different kinds of problems. Computing
Problems
is a field that applies everywhere, and so
everywhere. Yeah.
yeah,
Oh,
everywhere.
it's a huge horizontal field.
Yeah, yeah, very, very huge horizontal cuts across a lot of places. So
Cuts across.
that
Yeah.
was an interesting one. Uh, then the other example I was saying was I worked for this company that was trying to manufacture radiation detectors at the ports. Um,
Okay.
and I think it's been acquired by one of the defense companies now. And they were very
Okay.
nice too. So I learned quite a bit. That's my introduction into Python, actually.
Oh.
Yeah, because
Oh,
I
that's
never
when you picked
used.
up.
Yeah, and
Oh,
that's
okay.
where I kind of got interested in it. But because I still was
And
like, I'm still a C++ plus plus guy, and I think they
oh,
even
yours.
needed me to do maybe even some Perl back in the day. Yeah, I used to
Oh,
write
okay.
some Perl too, from the
Okay.
days of yore,
From
when dinosaurs walked the earth. Yeah.
okay. So and then how did you? If interesting. This wasn't on a question. So how did you get into Linux? How did you? What?
Linux. At one point in time, if I remember correctly, uh, so I had the way I got into Linux was our operating system's book was this book from Tannenbaum about
Tannenbaum. Yeah,
Linux.
Andrew Tannenbaum.
Yeah,
Yeah, the
and
famous book. I remember that book.
over time we started hearing rumors of someone converting Minix into another version of Linux, right?
Linux.
Of
Yeah,
a Unix called Linux then. So
Linux.
I
Yeah.
I was actually interested in Linux pretty early in the day. I just never followed
Okay.
through to be completely in that space, right?
Right.
So yeah,
Okay.
yeah. So
Interesting.
so that's how I got into Linux. Yeah,
Okay.
and in
Okay.
Unix in general. When I was at IFE, one of my internships was here. Don't laugh. Was at
Okay.
NEPA of all places.
I'm sorry. I'm
But
gonna laugh.
you have to laugh, but of course, and this is how I got introduced to Xenix, right? Because they had a
Really?
big
They were using all those systems at NEPA?
yeah, 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 they were. How do you think they used to print their old green and white paper bills back in the day?
Oh, those paper, those
Yeah, yeah,
famous
yeah, with all those monochrome
bills.
printers. Yeah, those. those monochrome printers that would never die, right?
Yeah.
Those things
Forever.
were
Forever
indestructible.
built.
Yeah, yeah. So they had all these interesting systems,
Right.
and yeah, that's how I got my introduction to Unix, right? Proper
Interesting.
Unix. And I think,
Proper unit.
if I remember, they were using System 5 because
Okay.
Xenix is a variant of System 5. And I think
Okay.
Xenix later, I think some of the technology later got acquired by SCO, Santa Cruz operating systems, and it became SCO Unix, right?
Score Unix. Okay.
Yeah,
Okay.
SCO
Okay.
Unix. Yeah.
Okay. Okay, so how did you then transition into Intel, which is where I
Oh,
met
so
you
that was from
when I
graduate
was
school.
an internship?
So there was a friend of mine.
Okay.
You probably know him, Femi. You know,
Yes.
of course, this is just at the heart of the financial crisis, and I
Okay.
had just so because I went in grad school, I was doing one graduate program, which was a PhD in computer science, and I started another
Yeah.
one concurrently, which was the one in math.
Yeah.
And because I can't leave math alone somehow,
Yeah. Yeah.
math had to
PhD in
show up,
computer
right?
science, you finished, and then you started a PhD in math.
No, no, no,
That's a
no. I
separate.
didn't. No, I didn't. I was doing it concurrently, right? I
You
just
did them
exited.
concurrently.
Yeah, I was doing them concurrently, and the by the school rules, you couldn't combine the coursework, so it had to be
Oh,
separate. Yes, you can't use the coursework of one for the other.
so you were
So
doing coursework for math and you're doing
that's
coursework for computer science, and you couldn't
correct.
interchange them.
Yeah, you couldn't.
And that's a boss move right there. And you
Yeah, right.
and you passed all of them.
I managed. Yeah, but
Did
but
so,
I was away from math for so long. After that, once I started the program, then it took me kind of like a year to kind of reset my brain to understand the language again because it's like another language, and it took me like a year to get used to it, the terminology, the terms, and
right,
after a bit, then I understood what was happening, and so yeah, and
right.
then everything made sense. All was right with the world.
So what was your pathway? What were you trying to do with the? Because I know you didn't
It was
complete it,
fun. It was
and
fun because it was keeping me sane. That was what was keeping me sane because this I really like.
right.
Like
So
this I really.
what was your thesis? What were you trying to do with the
What I
PhD in
was trying
math?
to do was either something with partial differential equations or dynamical systems, right?
Okay,
Which are how we represent things that happen uh, in time. Well, of course, everything essentially happens in time, right?
right.
uh, Things that happen in time that are complex,
Okay.
and the relationships between these things tend to be very complicated, right?
Yes.
Sometimes they're
Yes.
related to time, sometimes they're not really, so those things are called autonomous, right?
Okay.
But then because have all these multiple variables that are related, they end up being mostly PDEs, or sometimes
Right.
we call them differential algebraic equations and so on and so forth, but which are
Ah. Okay.
representative of dynamical systems, which means things that evolve in time,
So
meaning the
on change over
characteristics
time.
that change can change over time based on more one or more variables, right? So interesting stuff,
I'm I'm thinking honestly because I did math and computer science as well, and I'm
right?
thinking that my math got bad the moment I got this computer science thing going. And
Right. But then there's a lot of math in computer science, especially of the discrete kind.
right,
And you would think that it would make things easier, but it actually most times makes things harder.
interesting.
Yes, yes. Distilling a problem into a yes or no question often
Yeah.
makes it harder because it is not representative of
Ah,
real life.
of real life.
That's a
Oh,
problem, right?
true.
Because if you think about numbers, right, real numbers, right, they are
Right.
uncountable, in fact, infinitely uncountable numbers between 0 and 1, right?
Wait, what? Infinitely uncountable numbers between
Zero
1?
and one, yeah, those are
What,
your
zero
real
point
numbers.
0.1, 0.001, 0.
Right. And it's inside there you have your rationals, right?
Oh,
Right? Your
now that you
rationals are a
mention.
subset of that. Your irrationals are a subset of that, right? Right.
So would you say there's a lot of research in math that is still fun compared to computer science? I'm thinking I should just go get a master's in math and just I don't know, re-energize
Go
that
ahead, go
interest.
ahead. I think it will be fun. You pick.
That's what I'm looking for. I'm looking for the fun part.
Look for the photo. If find out something you're interested in, and just do that. And I know, coming from Nigeria, once we start talking like this, people are like, first world problems. Now, because they're not job finished, as they
Well,
say, right?
anyway,
But it is good to
moving
be
on.
able to have those first world problems, right?
Yeah, yeah, fair
Yeah.
enough. So moving on. So you say you met Femi. So how did Uncle Femi? Because I know him very well. Very funny.
Yeah,
I should
Femi
actually
and
bring
I,
him on this
Femi
podcast.
did his undergraduate in Nigeria, right?
Yeah.
He did physics, right? Uh,
Oh,
so
okay.
yeah, so I knew Femi all the way from Nigeria, and so I reached out to him. Femi worked at Intel then. So
Oh,
yeah, and he was, oh, we're hiring. I'm like, oh, you're hiring in this
yeah.
environment where it's really difficult to get a job.
Oh,
Yeah, so sure, send me your name and your resume. I'll put it around, and he did that, and I think that same day or the next day, someone called me.
okay.
Day after that or so, I had an interview, and that was
Okay.
that.
Okay. Was that
And
interview
you
with
know who I
Jay?
had an interview with?
Jay? I was gonna ask.
Yes!
It was Jay.
Yes! Yeah, it was
Oh
Jay.
wow.
My man
And I
Jay.
think Jay had just started that group. I think he had just started this whole performance. No, he was been working on the whole performance thing that
Yeah, yeah,
by
yeah, yeah, yeah.
then.
Yeah, I mean, it used to be Baco and Michael back in the day, and
Yes.
then went to Jay, and now Jay hired Tarina, me, you know,
Right.
Justin, and then the thing started growing. Yeah,
Interesting. So Jay also hired Justin. You guys came in together, right?
yeah. Justin probably came a year before me or so,
Okay.
or a
Okay.
few months before me.
Okay. Okay. So um how did you grow in that role? I met you when you were probably 6, 8 years in.
Right. Well,
And
I
I came
mean,
for an
there was a
internship.
lot of learning,
How
and there's a lot of learning because hardware is becoming much more complex. You have
right.
core, you have on-core, you know,
Yeah.
those have followed different trajectories. There's the thermals now. I mean,
Right.
there are those on the material science side of things that are actually trying to
Right.
create the wafers. So it's a diverse field. Right? I mean,
Wow.
now we just call it a chip. Now we call it an SoC, right?
Yeah, SOC, yeah.
Right, because you have
And
all these
and all this,
nice
and then we
interconnect
have
technology.
chiplets, and we have
Mhm.
chiplets and all these things as well
Right, right, which are several SoCs put
together.
together as one, right? So, I mean, there's been a lot of evolution. So that's the story. Things will change, right?
Right.
Things are going to change,
Mm,
and that complexity has to be understood, and in order for us to make use of it, right? So that's all that's
interesting.
happening. Yeah.
Okay, so um, and I remember your very famous tool. I always talk about this tool, Olu's tool.
No, no, no. I mean, all our problem was just that. Well, I mean, we started with Excel spreadsheets and all that.
Yeah,
And
Excel
spreadsheets are not
spreadsheets.
bad. I mean, they get a bad rap, but it's just that it was very
Right.
hard for people to collaboratively work on separate things, and
Ah,
sometimes being able to do things to get the same quality repetitively, right? It can be hard, and so it's that informed us trying to build this tool that will help us to do that. And the tool would also evolve from allowing us to be able to do our analysis quickly,
yeah.
which means we could also focus on other things like working with our partners on the thermal
Right.
side, on material science side,
Right.
on the product and marketing side,
Mm-hmm.
and the corporate strategy side, to make
Right.
sure we have a compelling product and the
Right.
product is well segmented, you know,
Okay.
because they have different performance profiles within
Profile.
each product segment and all that stuff, good stuff, right? So that's the advantage, if your work takes you faster, then you can kind of augment your work and make your work more useful,
True.
right? Right.
True.
So essentially, that's what I think it allowed us to do. That's the important thing.
Do you still know if they use that tool at Intel?
I haven't asked recently, but I'm sure they do, and I'm sure they've evolved it. I hope they
Oh, okay.
have.
Do you think there's anyone else that can maintain that tool?
I think they should be. I mean, it's reasonably simple.
No, it's not.
So
I've looked at the code base. No, it's not.
there's a C++ back. So essentially, there's a notion of computational graphs, right?
Right.
So you're working
For
in
those
computation.
who don't actually understand what we're blabbing about, can you just give a quick overview because people are like, what are they talking about?
Okay,
It's so go
so
ahead and
think of
just
it. We're
explain.
trying to predict the performance of, say, a particular chip, right, and all the families related to it, right? And the families related to it, it means that you make certain changes or ISO changes, we used to call it back in the day,
Right.
um, to one particular part. Maybe you increase the cache or you increase the clock frequency, you
Right.
know, what happens to the performance once you do that. And so what we did was, well, we now laid all these different changes on a graph. Okay, if you want to make the L3 cache this big or L1 this big, this is what
Right.
we expect the impact on performances. And so literally you can walk this graph to reach a particular product that you desire, right?
Right.
Maybe number of cores, number of threads, those kinds of things. So that's the foundation. And then
Okay.
you can now programmatically, even at so each product is now a node, and the ISO connections are edges, right? So
Right.
then you have a graph, and then also each node can be also more complicated. Say, for example, okay, if you say you make changes and you navigate to this product, you know how much delta of performance you get. But
Right.
even the node can still take over the computation and say, hey, there may some other things that you're not accounting for that I can
Correct.
account for. And and there's code that represents that change. And so that
Yeah.
code will take over and do that more complex calculation and represent the results and give the feedback.
That's why I tell you that no one is maintaining that. Let's move on.
No,
That's why.
okay,
That's why I tell you no,
okay, and that would
because
be
only
very
you could have
sad,
come up with
but
that
I
code.
doubt that. And because we tried to do one of the things we tried to do was we tried that when you had a new product and you defined its characteristics, you could actually
Yeah.
generate a lot of skeleton code that already does most of what you would do, and
Oh.
all you just have to do is augment that code in Python and say, hey, um, this is what I think how this will perform if I change this from this to that, and so on and so forth.
Interesting.
Right.
Okay.
And I think the last thing we did was before I left Intel was with the asymmetric cores, right, where there's like the big little that ARM does, and worked out how what the, at least a reasonable performance model for that, what it would look like. Right? So we tried
Okay.
to do that, and I think we were, I would, in my view, moderately successful.
Right.
And I'm sure it's probably evolved by now because it's all the rage now.
Right.
So we'll see. I'd
Okay.
be surprised if they're. I'm sure they're evolving it. And what we also did was we now use gRPC to connect with the
Yeah.
thermal aspect of it, where another group does the
Oh.
modeling of that. And so we use
And then you
gRPC
can
to
cook. You can
and
pick
we
that
so we
data
could do the annealing and say if you given this thermal characteristics, it gives
statistics.
these frequency and so on and so forth, and then now we can get the performance right.
Oh,
Right. So
that's
so so
cool.
we
And
did
then you
all that before I left. Yeah.
took your experience. You went over to Meta. So tell me about that transition to
It
Meta.
was a little bit different because um, I wouldn't like to talk too much about it because it's currently where I work. But I would say
That's fine.
what we do, the team I work in does strategic planning for the data centers. So I'll build
Okay.
out for of greenfield data centers, how we design
Okay.
new ones, um,
Okay.
and how do we retrofit old ones, those kinds of things.
Okay.
Do we want to deploy our racks? What kind of racks can we deploy?
Okay.
How do we deploy these racks in such a way that we minimize stranded power, for example? Stranded power essentially is just power that is available but you can't use. And because power is at a premium, you don't want that, right? And of course, that reduces your what we would call your power usage efficiency of your data center. Um, so
Okay.
that's what we're trying to do. We're trying to always improve our power usage efficiency. Right?
Okay.
And,
Okay.
yeah.
And so, with all this significant tenure at Intel and yeah, Meta right now, you've seen the tech industry from a very good from a very good vantage point.
Right.
So, what key industry trends or technologies have you seen evolve, and how did this influence? How has this influenced your career? What is that
Mm.
thing that you see as a trajectory? Like, okay, should I
Okay.
be here? And things like that.
Okay. So let's have a little bit of a history here of what's happening. So remember,
Okay.
I was talking about the fact that we had 64K of
Yes.
memory to play with
Yes.
back in the day, or before
Yes.
it was even less. You had drums, magnetic drums, and all that stuff. So memory used to be very expensive. Now,
Right.
as
Yes.
the manufacturing processes have improved even more exponentially, what has happened is that memory has become what? Cheap.
Cheap. Yes.
So the kinds of problems and how you solve certain problems
Right.
has changed because you have cheap memory. So the
Right.
first thing you saw was big data.
Yes.
Now, the second thing that you're seeing is AI coming in because now they can deploy these models on these GPUs because
Right.
they have a large amounts of memory and
Yeah.
because the improvement of your manufacturing processes, you can keep within a reasonable thermal envelope
Right.
multiple processors working at once, a lot of
Yeah.
parallel processing happening, right?
Right.
And so, because many of these problems are embarrassingly parallel, especially
Right.
essentially a lot of them are based on matrix multiplication essentially,
Yeah.
right?
Yeah.
So if you have an algorithm for multiplying matrices very fast, uh, then of course you're going to be able to do current ML very fast because that's essentially what's happening. Then
Right.
then of course there are some math breakthroughs that have also happened that helped as
Okay.
well. For example, uh, stochastic gradient optimization
Right. Yeah.
(SGP). Yeah, so that helped a lot too. So uh, I would say memory being cheap, hardware being more
Yeah.
reliable,
Right.
and being able to have multiple processing elements, cores, whatever you call it, working at
Mm-hmm.
once, right? If because of Moore's law or whatever variant of it you can think
Right.
of, now you have a lot of computing power
Yes.
in your hands.
Yes.
Now it's a question of what do you do with it, right?
Right.
And that's essentially the story of the evolution. I mean, there's lots of video everywhere. This is video, right?
Yeah.
That we're seeing so cheaply, you know.
Yes.
So the miniaturization on the computer hardware side. There's also
Yeah.
been a lot of work in data throughput happening because we have fiber optics now. You
Right.
thank you, Corning. Thank you, Corning would say. Um, and now, I mean, terabits and terabits of information can go through
Right.
your fiber optic lines now. And so now you're seeing, well, data going through, using data is now cheap,
Right.
essentially. So what can you do with it? Can you learn with it? Um, can you use it to do something useful? Right?
Right.
So, so traditionally we didn't think that there was a lot of data out there, but think about it.
Mm-hmm.
Let's even say your human visual system is 4K,
Yeah.
right?
Yeah.
So it's probably better than that, but who knows?
Yeah.
So that's more than 1 million pixels, right? And each, if you say 8 bits for each color, and now for transparency, that's 24-bit at the
Okay.
least, right? So you see where I'm going with that, right?
Right.
Uh, and if so, that's a lot of data happening every
Yes.
second,
Right.
right? So even speech, it's a lot of data
Speech. A lot of
every
data.
second,
That's true.
right? So these were things we were aware of, but we couldn't take advantage of. Now we can take advantage of all that data. What can we do with it?
Right.
And this is
Right.
what is pushing computer architecture now.
Right.
Now we're talking back of reviving the nuclear industry because, well,
Yeah, because of how much
this thing
power we
consumes
need.
a lot of power because we need a lot of them to work together,
Right.
right? So you could see that influence on the industry right now.
Right.
So they're going to be large scale computers. There's still going to be
Okay.
computers at the edge, like our little
Right.
phones, right?
Right.
Yeah, because that's where the data input is going to come from, right?
True. You want to do inference and you want to do training at the edge as well to, in order to take off
Right, right,
load
right.
from the
Or
central
so,
computers.
that's also some form of distributed computation, right? Because you're saying, well, I want to do some little pre-processing at the edge, because
Right.
I may not be able to do everything at the server side,
At the
right?
center.
So I want to
Yeah.
do some pre-work so that the load that the server side needs to carry is a little bit less.
Right.
Right.
Right. Right. Okay. So now this is for, information for international students. Given your extensive experience and insights, what would you be your advice for aspiring engineers, computer science people,
Okay,
international students that are looking to come in and the career path? What would be, you know, what would be the advice you would give internationals
okay.
that want
So
to
so
follow the same path?
so now, if they understand where we're situated in the computing continuum in the history, right?
Right,
Where now there's a lot of data, we need to be able to process it fast.
right,
Uh, any spectrum of this that enables this is actually
mm,
a lucrative career. It doesn't even
right,
have to be necessarily AI. If
right,
if you are just simply an electrician that is very good at maintaining electrical hardware and electrical systems, transformers, you're going to be in demand because they're going to have to
right,
build data centers. Data centers are going to have transformers.
right,
You see what I'm saying? There's going to have to be
yeah,
intelligent delivery systems.
right,
These power delivery systems have to be redundant, right?
right,
Right? If you know how to do
mm,
that,
mm,
you have a career. Presto.
that's true.
All right? Because
That's
that's
true.
going to
It's
happen,
very true.
right? Um, but I always want my advice to people will be don't necessarily there's nothing wrong with pigeonholing yourself, but it has its risks. You know, uh, if you're going to do, I would say still do computer science. Don't necessarily focus at AI unless you're at the graduate degree level. That would be my advice. You know,
Okay.
don't narrow yourself to AI because AI could be all the rage today, tomorrow could be gone because there was an AI winter at one point in time. These neural networks that we have today are not necessarily new. The ideas are
Right.
over 40 years old, right?
Yeah.
40,
I think,
50,
and
60 years old. Yeah.
I think to add to that, at the time when you had the neural nets, you didn't
Hmm.
have computing power to catch up with that,
Right, exactly.
and you also at the same time you didn't have data in a format that could help aid the training. So it was
Right, right, right. And part of also the problem, you have this narrowing of mental scope that typically happens when
okay.
you're limited by the reality of the opportunities you have available.
True.
Let me give an example of that. Um, the neural networks in the past couldn't really be so big, but because there was no hardware that could support it.
That could do
So
that.
why
Yes.
come up with that kind of architecture if it's not going to
When
fit in any hardware? There's no
yeah.
point, right?
Yes.
And so that's also the other issue. And this is also true for folks international students that
Right.
I mean, maybe your pressing problem is not AI right now, where you're coming from,
Right. Yeah.
where you're struggling to even get basic services like power,
Mm.
sanitation, water.
Right.
And so the question, it seems all pie in the sky when someone was talking about AI and robots and
Right.
drones
Right.
and computer vision, and you're like, no, man, I'm just looking for my next meal, right? So,
Yeah. Exactly.
right, so I want to be also sensitive to that, um,
Right.
and say, ideally, all this technology is meant for mankind for good purposes,
Right.
for the benefit of mankind. And so, if it's not helping your situation, then the question is why are you doing it,
Why?
right?
Why are you doing
Right,
it?
right.
Yeah.
So, I would advise, people look at this computer historical evolution and position themselves where, you can be a nuclear engineer, you're building new
Yes.
nuclear reactors, right?
Nuclear
You know,
reactors. Yes.
yeah. So, I mean, and there are all sorts of associated jobs, people that do control systems, there are even
Yeah.
control systems in the power delivery that comes to data centers and stuff. So there are lots
Right.
of associated fields that you could work with,
Work with.
and
Okay.
and I don't want to even downplay trades, even things like being a carpenter, right?
Yeah.
If you can
I've
help
I've
people
noticed.
now there's a lot of research that has gone into renewable um, building materials. And now there
Right.
are some companies that are out there that have done the research and claim that there's a way you can treat wood where the wood will actually be stronger than steel.
Oh wow. Okay.
Yeah. So, and
Okay.
so, I mean, so if you can do that in a renewable way, I mean,
Right.
you don't necessarily have to be in the computer science industry. And
Right.
my belief is that you want a society that is also diverse. You want artists. You want a society is no fun
Hmm.
if all of them are computer scientists. Then
Hmm.
we have no music.
Yeah.
That's not a fun society. I mean,
That's
if
a fun
everybody's like
society.
us, it's just not going to be a lot of fun, right?
Yeah.
We
That's
have to
true.
have art.
We
Some
have to
people are
have
very
art.
good at
Yeah.
art.
That's true.
Some people, Photoshop or Adobe Premiere Pro or whatever these video manipulation softwares exist
Tools.
that they're very
Yeah.
good at, and they can do a lot of creative stuff with.
Yes.
So there's also that industry. Um,
Right.
so I wouldn't want people to. There's architecture itself, new kinds of
Yeah.
architecture. Climate
Yeah.
changes. Some people have different views of climate change. I believe we're seeing it now.
Yeah.
I mean, places like where I originally came from, very hot. So
Yeah.
if you notice, then why is everybody building brick buildings and cement buildings in the
Yeah.
same way? Your
Yeah.
environment is hot, so you should build buildings in such a way that the heat can easily get out, or is
Okay.
diffused, right?
Okay.
So a lot of buildings you would expect in Nigeria, for example, would be white in
Yeah.
color, or maybe even made with mud, right? Ceramics, because
Yeah.
they have nice heat properties, right?
Yep. Yeah.
Uh,
That's true.
right? And that
That's
will
true.
you would
That's true.
avoid a lot of painting, right?
Yeah.
One would assume that our engineers would understand our soil topography and geology more than any other group of people. And now we have
Right.
specialized materials and since we know our topography more than anywhere else, we could probably
Yeah.
build 100 kilometers of roads in less than 100 days, right?
Yeah.
You know, I
True.
mean, because I'm still shocked that in Nigeria now, we still can't even provide pipe bomb water. It's that bad. And this is a
Mm.
problem the Romans solved
Yeah.
thousands of years ago.
Years
I
ago.
mean, so
Yeah.
it's not a soft. It's
All
gravity,
right.
right?
Problem. Yeah.
Yeah, I'm not trying
Gravity.
to
It's a
throw
gravity
shade.
problem.
I'm not trying to throw shade. I'm just saying that also as well to people that we there are lots of problems that can be solved, and there are different ways of solving them.
Yeah. Yeah.
Different tools. Um, Computer science is one of our tools that we can use.
I get your
And
point now.
yeah,
Yeah.
yeah, and there's a viable career in almost anything if it's done very well. And I
Very
also
well.
want to emphasize, and especially ethically, right? It always pays you
And,
back in the long
yeah.
run, right?
So that I said I was going to leave this for the last. So speaking of your experience living in the US,
mm.
You know, what has been the interesting bits, the showstoppers? What has given you like pause, like, oh wow, really? What- and over
Hmm.
the years, because you've been in the US what, almost 20 years
Yeah,
now?
almost 30 years now. Uh,
Yeah.
my thinking is, uh, you need a lot of, and I know people just tend to misuse this word. You need a lot of mental flexibility and diversity of thought to solve a very complex problem.
Okay.
Uh, and, and one of the complex problems you have is dealing with even human perception, right? Or
Right.
group perceptions, right?
Right.
Uh, those are not easy problems to solve because, for example, human outlook or human history creates society,
Mm-hmm.
and that society has problems just simply because of human history. And
Mm-hmm.
just being able to access the history can help you situate in time how a problem evolved to be what it is today. And
Right.
it can give you an idea of what the solution will look like,
Right.
or the landscape of solutions that you you know. And what has been surprising is that sometimes people don't want to do that, right?
Okay.
Which I find a little bit weird, right? It's like this thing that people sometimes people want to learn the hard way, the only way.
Right.
That's been very difficult sometimes to
Right. Okay.
deal with for people, for me especially, in my experience. That yeah, these are interesting human problems that that I thought that I had escaped.
But
But now I see, well, oh, but then it goes to say, well, they're humans too here. So,
yeah.
so that has always kind of shocked me. That in some ways, I think what has helped a lot of Western societies is that uh, the elite sometimes have realized early the need for change,
Okay. Okay.
and they tried the best that they could to change the system. And sometimes they succeeded and sometimes they did not. Right?
Okay.
It's not necessarily guaranteed, but and that's what I see. Uh,
Right.
uh, Unfortunately, what we've had back home is our elites don't think that way. I think they're just
Right.
socialized to for just immediate gratification. That's my observation. That
Right.
this long lack of long-term thinking, taking the long view, thinking about stuff really critically, um, and I find that it's a problem sorely lacking. And I'm saying this that I had to make lots of changes. I had to learn a
Okay.
lot. I had to really, really examine why are you doing what you're doing, you know.
Okay.
Well, because this is how people do it.
Right.
Sure, but how is it helping to solve this particular problem?
Right.
And then I get into this loop. I've had to reason about a lot of things.
Okay.
Like for example, before I came to the US, I was saying, well, spanking children, there's nothing necessarily wrong with it, you know,
Right.
but I would have when before I came here, I would have said spanking would have been the first instinct, because
Mm-hmm.
that's just how everybody did it,
Yeah.
right? But now I see, well, it's the last instinct.
Right.
Children actually listen, all right?
Yeah.
They listen, and now I'm not saying, that the people that spank are bad. No, that's not what I'm saying. I'm just
Right.
saying there are more optimal ways that are more meaningful, right?
Right.
Because the reason why I'm saying that is that you don't want a teachable moment to be associated with pain.
True.
And people will
True.
avoid
True. True.
teachable moments. You see, this is a problem that's built into our culture that
Yep.
we don't realize, right?
You
Just
realize.
even
Yeah.
that little thing that we've distilled teachable moments to be associated with pain. So people avoid teachable moments. See,
Mm.
and that will create cascading problems just from that alone, right? That
So
little thing.
what should international students watch out for? Because
Hmm.
it's always very easy to watch the news, watch the movies, see what America looks like. I mean, I've been here. This is my ninth year, and
Hmm.
this last election kind of changed my perception of this is the real America. There's nothing
Hmm.
bad about it. It's just a realization.
Okay, okay,
So what
okay.
what should
I'll touch on that. I'll
international
touch on that because I think,
right?
you know, um, America has a very rich history. Some good, but some bad. Just like
Yeah,
any normal complex society, there's always that problem,
right,
right? And the question is, what do you do with it? What do you learn from it? How do you
right,
react to it?
right,
Um, how can you help to move the ball forward in a
right,
way that is helpful, right?
right.
This is one thing I've learned, not to just join things just because people are
Okay,
doing them, right?
right.
I don't think it's, and maybe this is my point of view. Well, as an African, I think, you know, trying to take on Western culture wars is, I don't think it's important,
Okay,
you know. We come from a communal aspect. So what is best for your community? How can you help your community? I would
right,
rather think that way.
right.
And how do you help to move that ball forward? Say, for
Right.
example, let me give you an example of how that is. Okay.
Okay.
Uh, my uh, professor uh, that I worked with in my thesis advisor
Right.
um, got grants from the NSF, say, for example. Okay.
Okay.
And part of those grants funded my PhD, right?
Right.
Yeah, now someone will now tell me, oh, there's waste in NSF. Cancel the NSF. For
Right.
those that don't know, NSF is National Science Foundation, right?
Right.
I would tell you hell no,
Yeah.
because the NSF made me part of what I am today. And
Correct.
there may be some mistakes. Yeah, sure, fix that. But the NSF
Right.
does a lot of good. If there's the NSF probably funded Sergey Brin and
Yeah.
he's co-founder of Google, right? So
Yeah.
you
Yeah.
see where I'm going with that. So
Yeah.
something that has been of such good to so many people, we want to maintain that,
Right.
right? Right? If you see all these books here, some of them have this
Mm-hmm.
yellow hue. They're from
Yeah.
they're most
I
likely
see
Springer
them.
Verlag. If you open any of these books, the math ones, computer science ones, you see the most of these books are either sponsored by U.S. Army Research Labs, Air Force Research
Ah.
Labs, U.S. Navy Research Organization, NSF. So you're
Right.
seeing that all these organizations are sponsoring the creation of knowledge and
Right.
understanding. You want them to continue that because
Yes.
that sponsoring of creation and understanding has had a compounded effect over generations. You
Yeah.
want to
It has.
you want to support that,
Yeah.
right? And if you are still in Nigeria and you're a decision maker, these are the kinds of things you want to establish,
Yeah.
influence, and make happen
Yeah.
because they have compounded benefits over
Yeah.
time, right? So these are the ways I prefer to think these days, right? Because
Okay.
you know it's the last few years, you know,
Mm.
the things that have happened, so to speak, are not necessarily just like you're saying, they're not
Yeah.
new,
Yeah.
right? They're not new if you are a student of America's history. And I would
Mm.
say if people should go and read the Federalist Papers, people go
Right.
and read about the American Revolutionary War
Revolution. Yeah.
and understand all the wars of 1812, all the things that
Yeah.
happened, Bacon's Rebellion, all these things. Once you read them, you understand that this is not new. So don't
Yeah.
get trapped in the here and now,
Right.
right?
Right.
Understand the history,
Yeah.
and the history will help you understand the here and now. So what do you
Right.
want to contribute into building a better future for America?
Gotcha. Yeah.
Yes, so that's where you want to place yourself.
Okay.
That's where you want to
Okay.
place yourself. And I understand some of the anti-immigrant sentiment is not necessarily helpful.
Right.
Uh, I'm not a fan of it, and I'll say
Right.
that openly. I'm not a fan
Yeah.
of it, but it
Right.
is what it is.
Yeah.
Um, you know, this has existed in Western societies from time immemorial. It goes
Yeah.
sometimes it goes up, it goes down. Just when you
Yeah.
think that, oh, it'll never
Oh,
happen, it rears
we're
back
making
its ugly head.
progress.
Yeah,
And then it just comes up
it
again.
rears
Yeah,
back its
and
ugly head. So
I think it's the biggest takeaway for me. Like, this is where you live now. This is how
yeah,
it
this is where
is.
you live,
So
and contribute your
let's
best to make it a better place.
contribute your best. Yeah, make
Yeah,
sure you
because your
can.
kids your kids are probably citizens and you want them to live in a better society. So
Right,
contribute your best to make sure you leave them a better society. That's your
right.
responsibility.
Yes, yes.
The same way I too am an American citizen now. As an American,
Yeah,
I want to contribute to build a better society. I want to build a better
yeah,
world.
yeah.
I want to leave
I
a
I
better
got
world.
my citizenship last month. So it's
Congratulations, man!
been,
I'm so happy for
yeah,
you. So
it's
happy
been
for you.
very surreal. I'm still trying to process it. I still don't.
Yeah,
I still
yeah, yeah. I know
I'm
it's
still
always
gonna
a
have to.
hard it's always a hard thing sometimes for immigrants. But you know, uh, the hard is actually good. It's because you're thinking about it and you're thinking about
Yeah.
uh,
Yes.
what's your place.
What's my
That's a
place? Yeah.
question that most likely will not be answered by you. Your kids will answer it for you. I think
Oh,
that's my thinking. That's my thinking. That's my thinking. That they will know. This is what my
they
dad
will
was.
know.
This is how he
Yeah.
lived. This is what
Yes.
he did.
What he did.
And that has been passed to me, and it's my
See?
choice to make some judgment about what that means.
Right.
If I think it's good, I'll join him in
Right.
whatever venture he did and move the ball forward a bit, and then they can pass it on to their
Yeah.
kids.
Yeah.
I take the long view about those things that way, right? I
Yeah.
think that's the way I think about it. That this is
Right.
where I live. Um, I want to contribute to it to make it a better place than what I met, right? So it is
Hmm.
where it is.
Okay.
And the same way, I left Nigeria 20 years ago.
Right.
Any way I can to help to contribute to make it better, I would also
Yeah.
take
You
that
do the same.
opportunity as well. Right.
Right. Okay. All right. Well, thank you very much for taking out the time.
No, no,
I know
no, no, no
we.
problem. But this is a very big topic that you
Yeah.
know that I know it gives a lot of interest. People are really interested in it, and and I
Mm.
know I brought it in a very broad scope.
Yeah. Brushstroke.
Um,
Yeah.
yeah, but deliberately, I just wanted to do that so that people don't feel discouraged.
Yeah.
It's not easy being an immigrant, leaving all that you know and coming to a new
No. And then you
place.
move here. Yeah.
And sometimes, you might have a good experience, sometimes you might have a negative
We have
experience.
a bad
You know,
experience. Yeah.
you know, those are parts of it, don't it's not new. I mean, if you read some of Nigerian founding fathers like Azikiwe came to
Right.
America, and you know what time they came, right? Some
Yeah.
some
Yeah.
came in the 20s and 30s, right?
Yeah. Yeah.
That's not a that's not a
Yeah.
fun time for an immigrant,
Yeah.
right? And
Yeah.
still make
Yeah.
something of
True.
it,
Yeah.
right? So make something of it the
Right.
time that you're here. And if you're here temporarily, make something of it. And when you get
Make
back,
sense of it.
contribute back to where you're going to and make it
Yes.
positive too. That's
Yes.
what's important.
Yes. Okay. Well, this was fun. I
Right, it
guess
was
I would
fun.
have to.
We did this recording again. Uh,
We did this recording again,
but
and
there's much more that I would love to say. Maybe one of these days we can have another podcast about some more uh, complex things in the sense of,
yeah.
maybe more towards, you know, as an international student,
Mm,
you're trying to find a job, you
right.
found a job, what do you
Right.
do?
Yeah.
Um, I hope everyone has a retirement plan. Yeah, everybody has likely a 401k, but you need
Right.
to plan for your retirement here, which is kind of a little bit
Yeah.
different from most of the Europe, for example.
Yeah.
Uh,
Maybe I should. Maybe I'll probably pen that down about retirement plans and stock
right,
plans
right,
and
right,
things like
right. And a
that.
retirement plan is not just even, and the fear and the danger here in America is that they make it seem like a retirement plan is always the financial aspect. But a retirement plan is
Oh,
also, what do you want to do
what
when
do you
you're
want
no
to do?
longer constrained by a day-to-day job, and you want to have something of choice that you want to
Right.
do. What would you rather
What
be
would that
doing?
be?
Yeah,
Right.
yeah.
Okay.
Maybe it's just you want to hang out with your grandkids. That's important.
Yeah, that's a
Yeah,
thing. Yeah. Yeah.
yeah.
Well, I'll bring you up again. I'll send you some messages and we'll figure out
Yeah,
this.
yeah,
I like the
you know where
401k
I live.
retirement. I
You
like
know
the
where I live.
401k retirement gist. So I think
Yeah,
that's a
yeah.
good one. Yeah, it kind of gives different perspective because if you're at different stages of life in America, where should you be financially, and things like that. I also want to do a podcast on in public sector, an episode on public sector.
Yeah, that would be
Should
fantastic
public
because,
sector?
yeah, because the public sector is a good sector to work in America. I mean,
Yeah,
yeah, that would be fantastic. And I know
yeah,
you've had recent experience in the public sector.
yeah,
Yeah, yeah, because
yeah,
if there's no public sector, we can't have a civilized society. So I think the public
yeah,
sector is extremely important. Um,
yeah. It is. All right. I will. I'll end the recording now. For anybody
okay.
else, thank you very much for listening
Thank
in.
you so
I
much,
hope.
everyone. Thank you. Appreciate you.
Yeah.
Yeah,
All right.
thank you.